Hello everyone, it's June 23rd, morning session. Let's do this. Nothing of concern. Alright, let's go for it. Reverse linked list 2. Given head of a single linked list and two integers left and right, where left is smaller or equal to right, reverse the nodes of the list from position left to position right and return the reversed list. Could you do it in one pass? So left is 2, so 1, 2, right? From position left, yeah, 1, 2, 3, 4. Okay, so we need to reverse this part. That's like a generic version of the linked list, reverse from end to end. So we can definitely the left doesn't really matter, right? It doesn't really matter because in the actual one, I think we have a dummy, so it's the same. So I probably have to use a dummy too, and then we just keep going, right? Keep going. We hit the first one. That is the one we need to convert, and then we do the magic. We say, I think we have a temp, right? And we say temp equals the next, and so temp pointing here, this pointing to nope, it's from here. This pointing to this, right? No. How do we reverse? Hold on. How do we reverse? Hi. We reverse by should be this pointing to this, right? And then wait, how do we reverse? I forgot. Hold on. Because I know we can do reverse in one pass. I've done it many times. Wait, how do we do that? Oh my god. Come on, man. We shall be able to do this. Hold on. So we say if we reverse, it shall be this, right? Oh, that's slightly different. Oh, that it doesn't matter. It doesn't matter. So yeah, so I think it's reverse will be this pointing back for sure, and we're gonna move on to the next one, right? And then this pointing back, we'll move on to the next one. So what we need is we need this one, and that's the tail. Oh, we can actually point this one back as well. If we point this one back, and we right now it's here. Yeah, so we just pointing this one back. So come in here. So we get temp is here, right? And then we point this one, point back, and that is it. That is it. But we need to get to the front. So which actually means we have to start the reverse from this position, right? So we pointing this one back, and we go here, pointing this one back, pointing here, pointing this one back, and then we go in here, and then we say, okay, we point everything back. Now all we need to do is, if we record on this one, that's the first one, right? So we record on this one. So we can say this dot next equals this one. So this will point in here, and this will point into this dot next. Oh, well, it is dot temp. This is a temp. Okay, I'm not 100% confident, but let's do this, right? And as we are writing the code, we might be able to get a better understanding of this. All right, so delete all that. Okay, we need a list node. Okay, so what we're saying is we're going to do, first of all, we need a dummy. Let's know next equals head. All right, so we always use a dummy, and then we're gonna have we're gonna have to pre and current, right? Pre and current. So pre equals dummy, and current equals dummy dot next, right? And then we're gonna first go to the left, right? I'm gonna say while left. Hold on, smaller than n. Yeah, that's fine. While left, current equals current dot next. Pre equals pre dot next, right? So if there's 2, then we go 2 and the left. Oh, I can do this for this in range left, right? So go 2 times, and then the current is at the head. So 1. Actually, it's left minus 1. It's left minus 1 because it's the position, which means we go left minus 1, right? So once we're here, we're gonna say left node, right? Left node equals current. This is something we will use later on. Now we're gonna start reversing. I'm gonna say for, so how many? 2, 4. That's two nodes, right? So from here, we're gonna go two times. So let's say 1, 2, 3, 4. It has to go 3 times, and then this is 1 time, so 2 times. Okay, so we say for this in range right minus left, that's the number of times we have to go. Right. Each time we are going to reverse. Right, I'm gonna say temp equals current dot next, and current dot next equals pre. Right, current next dot equals pre. Pre doesn't have to change, and we say pre equals current, and current equals temp. Right, so we finish, we move on to the next one. Do once, all right, and then move on to the next one. Do once, and then we done. So actually, I think we have to be plus 1. Have to be plus 1. So it's like, wait, I need to take 3 times. 1 time, 2 times, 3 times, right? 3 times. After 3 times, we come out. Now, when we come out, current is here, right? Pre is here. Everybody pointing back, right? So what we need, so current and pre. So what we need is to have left node dot next. So left node is here. So dot next point to 1. Dot next equals this. This is pre, right? And then we need a left node dot next equals current, and then return dummy.node.next. There you go. All right, give it a shot. Run. Pending. Finish. Okay, we have another test case, which is we can just do one. That's fine. So 1 on 1. Oh, it passed. Our last test case 1, 2, 3, 4, 5. So we're going to say 1 to 5. So we're going to reverse the entire thing. Yep, I think this one's good. Submit. Pending. Accepted. Nice. So yeah, not too difficult. This is very basic, slightly more complicated, linked list reversal. The idea is the same. The idea is the same as reversing the entire linked list, but we just need to record where the reversal starts. And at the end, we need to reconnect the reversed part with the rest of the linked list using a dummy node at the beginning. Is always recommended. So on, we only did a one run for 28 milliseconds or 86%. Okay. All right, very good. I'm pretty sure this is the official solution. It might be an early question. I might have done this before. I think it has solution, yeah. All right, this is 92, yep. Yeah, I've done it before. I don't remember when. Oh, it looks like maybe sometime last year. Yeah, 2 years ago. 2 years ago. That's July 18th, 2019. July 18th, I was in my internship. What's the solution I have back then? Oh my god. What is this? Helper position n, swap is allowed with front or turn node at position n+1. What? That is marvelously complicated. I don't understand. I don't want to understand. This is stupid. Yeah, my solution back then was stupid. How about this one? What the hell? Dummy while count. Yep, this is the same. It's the same as the current one. I don't know why I use a different solution. Oh, because this uses recursion. That's why I want to use recursion. Backtrack. Now, yeah, we're gonna go with this iterative. Yeah. I don't even want to check. There's no point. No point to check the recursion when iterative can work. All right, let's take a look at the recursion. Kind of don't want to just give it up. Let's take a look, because I forgot the recursion part. Recursion sprints from a similar idea that I use. Reverse an array. Huge advantage that we have is the availability of indexes, so that we can do to simply have 2 pointers, one at the beginning, one at the end, repeatedly swap. Yeah, that's how you reverse an array. I want 2 different pointers, one at the nth node from the beginning and the other nth node from the beginning. Once we have such pointers in place, we can repeatedly swap the data. Oh, you swap the data between the nodes and progress these pointers for each other, okay? However, we don't have any backward pointers in linked list, neither do we have indices. So we rely on recursion to simulate the backward pointer. Interesting, essentially the backtracking process in a recursion will help us simulating the backward movement of the pointer. Backtracking. So we constantly calling. Every time we call, we move forward, move forward, move forward. Once we're done, then we go backwards. That's backtracking. Ah, interesting idea. Interesting idea. Yeah, and then we won't do it. No, we don't do it. Keep recurse. Once we hit it, once we hit it, and then we swap the value, and then it's backtracking. Swap the value, backtrack the start value. Nice. Actually, it's not a bad idea. All right, let's implement this. I think I did exactly the same thing last year. No, 2019. I was like, okay, I have my initial solution, which looks nice, but how about the recursion? Okay, the recursion, let's see. What do we do? What we have is helper, right? Helper, we need a m and n equals right. Now I don't have to do this. It, right? This one doesn't return nothing. And we need the front node and the next node. Once we're done, we'll go back. How do we walk in front? Oh, we keep pushing the. Hold on. So at the start, we pushing the front left node, right? And then how do we keep the left node? And then we recurse. We keep the left node, we recurse, yeah, and then eventually we hit here, right? And then these two match, and then we swap them, and we're done. Now we go back over here. Oh, we just call it this one goes forward. Okay, we can call this one go forward, and then we can change and go back. I think we need to return. We need to return the node. Let's return the list node. I think we need to return a node, right? And we say if n. Oh, we also need to pass in the left node. That's going to be a list node as well. So we're passing a left node. We say n equals right. Right? If n equals right, then we say left node dot is a val. Oh, left node current node. Left node node. We do need 2. Right, and then node.val equals node.val left node.val. I'm going to return left node dot next. Right? Otherwise, n is not, then we just do hold on, let me think. I'm at the left node, right? Every time we're passing the left node, blah blah blah, go to the end. Once I'm done, no, it should not be, it shouldn't return the left node because it go back. I'm at the current node, somebody passed me a left node, right? And then I'm gonna know, and I'm done. And I'm gonna return. When I return, I'm actually at this node. Yeah, so return is this node. So it's gonna be return left node on next. Passing the left node, but we cannot use the true left node equals helper. Left node, we don't change that, and then node on next, n plus 1, right? So every time we go away, we just n plus 1, n plus 1, n plus 1 until we hit it, and once we hit it, we're gonna return. Once we hit it, we're gonna return the true left node, right? Now we have the true left node, then we can say true left node dot val and node dot val equals node dot val true left node dot val, right? And once we're done, we're gonna return true left node dot next, right? This one will happen until yeah, I think that's it. That's that. So we're gonna first go to the left. So for this, in this case, we don't even need a dummy then. We just say node equals head, right? For this range, left minus 1, node equals node on next. So now node looking at the first one, right? And then we're just going to call helper. Left node is node, right? Current node is also node. The n, what's the n? N is going to be left, right? Let's see, n is going to be left. N is going to be left, which means I'm at here. If it's left, that's 2, plus 1, 3, plus 1, 4. All right, help node, left. And it goes in. Left is 2 is not equal to right, so we do here true left node equals helper left node, so it's passing node, this node on next, n plus 1, so it'll be 3. Going inside, no, it's not happening, so I'm going to pass this, n plus 1, now we're going to be 4. Now coming up, it's correct, so we swap these two, right, and then we're going to return the left node dot next. So return this, coming back up here, this is what we have, this situation, right? So true left node is this, and true left node equals node is this, that's just the same, and then return true left node dot next. This is true left node dot next is this. Then coming back to the first level is this and this pointing together. And then what happened? And then the true left node becomes this one. And the node becomes this one. Now we reverse. I just I just undone all the work that I've done, which means we need to detect when they're the same. How do I know when they're the same? True left node, right? I mean, left node dot next. I think this one we have to check. Right? If true left node equals current node, and after that we're going to return none. If true left node, so I say if true left node equals current node, or true left node on next equals current node. Right, we'll do this first. Right, we'll do this first. After that, then we're gonna return none. Right? Else, return this. And then this we have to also check. So true left node. If true left node and this, yep, true left node and this or this, then we do this and we return. How do I? No, I don't think so. It's if true left node, right? Then if this, we'll do this, and if this, we'll return none. Otherwise, we return this. If not, just return none. Okay. Let's see. Not 100% sure. Let's make this one bigger. Let's see. Does pass? Nope. I don't think so. Output is empty. Oh, I didn't return. Return head. Gotta return head. Okay, this one's right. How about the edge cases? Well, actually, this is one of the edge case. Okay. How about the other edge case? Okay. Then this one's good. Oh, got a wrong answer. Huh. How? Check the 1, 2, 1, 2. Oh yeah, I was wrong. Hold up. So node doesn't go, so node is the front, right? And then we put the left in, and then we do the helper. So left node is this, node on next is this, n plus 1, left plus 1, 2. That's good. Now they are going to, oh, we have to do it here as well. We have to do this one as well. Can we, I don't know, can we like standardize this? Yeah, I know what I need to do, but it just feels like a lot of clutter. It is, the left node is true left node. I think I can do this. True left node equals this, equals left node if n equals right, else, and do this, right? And then if this, we do this, return none, or return this. That should work. Yep, try it again. Standardize it. Yep, there we go. Yeah, I like the recursion. Recursion is quite smart actually. But I do have to do a little bit trick here, right? So this is the recursion solution from the official solution. The idea is to create a backward pointer via backtracking. It's not backtracking, we didn't do backtracking. Via recursion, right? Via recursion. That is, we can return to, we can go backwards, right? We can go backwards, yeah, and it's hard to explain. Just read it, that you should be able to understand. Create a backward, right? A backward. So we say here, and then the tricky part is to figure out the terminating condition, which is when the true left node is the same as the current node. That's odd number of nodes to reverse, or the true left node dot next is the same as the current node, even number of nodes to reverse. It's also when this one runs slightly longer, 32, which is comparable, right? 32 milliseconds. All right, that's it. So we have two solutions, and I think this one is better than the one I wrote here. And this, oh no, that's not this one. I think this is the recursion one. Yeah, I don't know. This is the same. Then I call this front an M and an N. They use M and N to identify. Okay, that's fine. This is the swap, which can be done in one line. And return if they're the same, front, dot next, dot next. If n minus this equal to 1, I front dot next. So we replace these two, and then front dot next dot next. Why? Find the node at position. Back equals helper n plus 1 and minus 1. Oh, I think it's implemented differently. So we have m and n, right? So I want to find, oh, this is to find the back. This is to find the back. So given the front, we need to find the back. And once we're done, then we return back.next. So initially, when I call back equals this, that should give us the most back, but it's not gonna be. So we're gonna, and then and so we have different end condition. This one, the end condition is when n is equal to right. So it's different. Like I am here, looking for the front. I'm currently at the back, and I'm looking for the front. This is the opposite. This is I'm at the front, I'm looking at the back, right? So I say I'm on my back, and then keep calling, and once we reach this, front on next. That's the back. Once we reach this, front on next on next. Yep, it's the same idea, but actually I think this looks a little bit better with m and n, and then instead of having left node and a true left node. Yeah. All right. Anyway, so that'll be it for today. Did pretty well. I'll see you guys tomorrow.